technical طويلة هذا والله. Good afternoon, everybody. Hello. You guys can hear me at least. You can raise your hand on the Zoom just to make sure that you. Okay, good. Thanks. So I know now you can. All right. Well, sorry about this delay, but I was a little bit confused with the timing. I know it's 5:30 p.m. your time, it's 4:30 p.m. my time, and I'm in the Midwest. So hopefully next time I'll start earlier. So again, welcome to this course on the computer architecture. I know probably most of you or all of you have taken the 304, which is the digital logic design, which is the prerequisite for this course. So what today I will do, I'll just go briefly over what things we will be covering in this course. Number one, let me share with you my screen. Okay. Yes. Okay. This is the, let me open this guy here. Where did it go? No, not this one, sorry. Yeah. Okay, what is my file? Oh, okay. No, I know. Okay, I'm sorry. So there is this is 0 byte. Looks like it did not save on my computer. So the Logisim tutorial, I will post it for you on the Canvas. And this this one, we will be using the Logisim as our software tool. I think I will have about 3 or 4 assignments using the Logisim. We will go through one example together. But the overall course will be, let me open my slide, just 1 second here. Our introduction. We will actually ask the question, what is computer architecture? Okay, if I ask the question for my class here, what do you expect? What do you think? What do we mean by computer architecture? What is really at stake here with our computer architecture? We know what digital logic about. We know the gates. We know the digital arithmetics. Now, what do you mean by computer architecture? Anybody has a clue here? Tell me.
Is it like wait, you can hear me, right?
Yeah, I can hear you. Let me just
Okay, cool.
raise the voice on my computer so I can hear you better. Okay, go ahead.
I was going to say like computer architecture is somewhat, well, not somewhat. Is it just like just the insides of a computer, the hardware, like what you were saying, the gates, like the CPU, the RAM, just everything that's inside of the inside of the PC that makes it?
Yes, those are the components of the computer architecture. But I think you wanted to say to put them together, the CPU, the memory, the I/O, and how do they integrate and work as one system in order to deliver what is required from my computer in terms of computation, performance, etc., etc. So you are right, it's the CPU, or let's call it the processing power, the memory, and the memory, there are two folds: the memory that sits on the computer, on the next to the CPU, and the disk drives, or we call it external memory, and then the I/O devices like the keyboard, mouse, USBs, anything that allows us, cameras, microphones. So all of these will make up the computer. So if I will, well, this is what I was. Anybody wants to add anything to what we have just said here?
Okay, so let me proceed as follows. I want to show, just to put what I have said in a small diagram. So if I have a box like this, another one, and one more. Okay. If I say this is my CPU or processor, this is my memory, and this is my peripherals. And then I don't want to draw links between them. What I want to do, something like this. And I will give it another color. And I will call this my architecture. Okay, can you see my slide? Okay. And this is what I have. Each one of these connect to this architecture. And this whole schema now delivers also processing, computation, you name it. All these applications will be delivered right here. So my architecture, integrating my CPU, my memory, my peripherals will produce my processing computation. In order to understand how to proceed with this, we will come to the CPU, and that's one of the major topics which we will have. Okay, so I will get my CPU. And here I will see what does it take for this CPU to work. Now, this is my CPU is going to process my tasks. You write a program. You, if you go to the other topics that you must have studied or you will study, you write a program in Java or in C++ or in C, and then with this uh, program you compile it, and then you need to run this on a CPU. How do you run? How do you make this final step? Your instructions, your code goes into your CPU. Let's see, how many of you had Java programming? Can I see hands? How many had C++ programming? Okay, we have Jubril had C++. How many of you had C programming? Just C. Okay, okay, Alexander. How many of you did not have any programming at all? And I see that everybody had some programming, but some of you did not have either Java, C++, or C. For those who did not raise your hands for any language, what language have you taken in as a class? What type of programming language you have learned?
I took C, but I just didn't know how to use like the React thing, like with the hand. But I did take C in
Oh,
Python.
oh, okay, okay. So you did not know how to raise your hand, but okay, at least you raised your voice. Thanks. That's good. Okay, so you took C. Uh, Anybody took assembly language? No? Okay, let me ask specific. I have Miranda Clark. Did you take any language, any programming language? Let me start one by one.
Yeah, I wrote in the chat, no,
No.
but it didn't work. I took Java and then C++.
Okay. So you took Java and C++. That's good. How about Devon Wing? What type of languages did you take?
That's me talking.
Oh,
I
you
said
are
I
talking.
took
Oh, you said already. Okay, thanks. I got you. Who else I have? Jonathan Castillo Lopez. What type of languages did you take?
I've taken some C++, Java, Python.
Okay, that's good. So you're more advanced than me. I never took Python, but I know what how Python works. I see Jubril before you raised your hands. Miranda, we took. Who else I have? I have
I still haven't gone yet.
Samadarshi, yeah.
Yes. I'm taking Java and Python currently, and I believe I took C++
Okay,
a couple of
good.
years ago, but it's been a while.
Okay, that's fine. I just want to make sure that we all know what programming language is, and whenever you wrote a programming language, you run that through the compiler or through the development environment like JDE or the Visual Studio, and then it produces to you what's called .exe or .obj, correct? This is your program finally, which you run into the which you will run or you have to run it on your CPU. That's typical. We have used that. So you have a code, let's say prog1 dot exe. Assume that this the exe was generated by the compiler of Java, let's say, through the JDE. So that's what you have, and then you use the what we call it the run or execute. So you push a button. Let me call it run. So this program here, you need to run it here. And with this run, you allocate this program now to your CPU. Okay. Now, if you ever go to your, what is running on your CPU, let me do that as we speak with this Control Alt Delete, I believe. Okay. And then I will look at the task manager here. Come on my computer. Okay. Look, these are the tasks that are running on my CPU. I have the Adobe Acrobat because I have a program opened in PDF. I have Google Chrome. It's running. I have the Java platform on my computer. I have the Microsoft Excel. All of these are running. And when I watch my CPU, it says, let's say, could you see the percentage? That's the percentage of CPU being spent on my on the CPU by each one of these. So let me take, let's say, the Google Chrome. Let me keep it here on my Google Chrome. And I could see the change on my CPU, what it's consuming with this Google Chrome, 0.2, 0.3%, and then 0.2 again, and so on. And if I look here at the total, there is total percentage of my CPU which is being utilized by all these programs that are running. Okay, the reason I'm showing that is because you are not the only one who is running on the CPU. Definitely not. There are other programs, and as I have shown now a few minutes ago or a few seconds ago, here, look, there are so many. There are background processes 124, and here we can just count those. These are all background. So many, so many. Some of them take 0.1%, some 2%, some 0.5, etc., etc. There are quite a few of them. So let me get out from here. So I made my point. Now, the question is, who in the world prioritize these jobs like my program, prog1.exe, which I have just compiled, give it a time slot on the CPU, and how does this processor take care of all these processes at the same time? So all of these are called the runnables. These are running now, right now. How? So my question becomes, in which my architecture should answer me this question. I would say, how does the CPU execute all these programs increase the size here so we can see it. So that's question number one, which will be answered by now today. If you open your GPT, it will tell you, but it will just tell you that the CPU has to schedule them, has some algorithms. But what we will learn here in the architecture, we will see how the CPU program or schedule. So the answer by the architecture, it will tell me how the CPU, or I will tell my architecture, I will build my architecture. I am the one who designed the architecture. It's actually us here who will be responsible for building architectures or changing the architecture or modifying it or innovating a new type of architecture. So the architecture is going to answer me. And there are many different ways. Now, another question will be, when the CPU executes a program, at some point of time you need data, and I'm pretty sure you wrote some programs or you have seen some programs, or today I can just name one. Let's say if I am a doctor and I'm looking for a patient, and the patient is in front of me, and then the patient I made some test, exams, analysis, then I need to look up his records throughout the last 5 years. Let's say doctor investigates blood sugar level of a patient. And this is a program. Somebody wrote this program, one of us. Then when the doc needs all data for the patient, then the program that he is working on will stop for a second, for a short time, go and fetch the data from the memory, from the hard drive, let's say, from the external memory. Bring it to the program that asked for it. Then continue execute. Look, what I have said on those few words here. What's happening here? Okay. What I have just said here is something that my computer architecture would have to answer this question. What if I need a data file? The data file is in on the hard drive. So I will, again, let me insert this shape for me. I'll get a hard drive. I think I have the shape for it. Yeah, something like this. That's my files are here. Then somebody has to interfere and bring those files as close as possible to the CPU. Who's going to do that? Who has the time and the knowledge knowing that the CPU needs a file and goes finds the file and bring it and let the doctor with his program look at the files and then add something new and then save it back. This is what architecture does. That's we as programmers, and I'm pretty sure none of you at any point of time when he was writing the code was in your code you say, okay, this file I need to look it up and bring it. You don't do that. There is an architecture. Now, of course, the architecture, I need to be a little bit careful here. The one that will do it is the operating system, but the operating system does it based on the architecture you design. You design an architecture, how the flow of data goes from one location to another location so that you can make this happen. So I'm not going to go through all of that tonight. I just want to summarize this with an again what we are going to learn here. I will call it the architecture of the CPU itself, the memory architecture, which is the design of the memory, how it's going to be designed, and then the interaction, also the external or peripheral devices, how the CPU and the memory are going to relate to my keyboard, to my mouse, to my microphone, to my camera, to my touch pen, etc. All of these are peripheral devices, to my printers, to my external files, to the cloud. Today we have all of these plenty of things. So how we are going to do all of that. And then the interaction between all. And at the end, you need to make sure that the objective is to process applications with optimal performance. Optimal performance means you have to be fair for all of these stuff, which I have just shown a few minutes ago. Let me put them again. Oh. See here we have 8 applications running, or 17 already, and 124 background. So 17 plus 124, that's 134, 141 total. So you need to be fair to process applications with optimal performance. Optimal means fair, means produce sometimes the urgency, take care of urgency, which means at some point I have to be unfair or to change my policy. There is an application that needs to run now, and I have to give it as much CPU time as it needs now. I cannot be waiting for this application to run in front of it, maybe 100 other applications. So you have to take care, you have to be fair, you have to be optimal, but you have to take care of urgent applications which require immediate attentions. Like when you have a virus coming up undetected, and you will say, oh, let me wait until I execute 20 or 30 other processes before it, and then if times come, by that time your computer is out of service, which is absolutely not acceptable. Okay, so we need, these are the things which we'll look at. We'll look at the architecture of the CPU, scheduling, what type of processes, how does CPU execute instructions. I write the command if x equal 0, then y equals x plus z. That's my talk. Or today in Python, you will actually use something like in our natural world to say, let the sales be more than the or let the revenue be more than our cost. Then the profit will be revenue minus the expenses. So you could write it in this manner. How does the CPU understand your language? How does the CPU understand Java? How does the CPU understand C++? And so on. So we need to take care of that. How does CPU schedule processes? Then the memory architecture, what data you want to keep in your memory, what data you can keep on the hard disk, and you bring it only whenever you need. Can you execute instructions in parallel? Sometimes your CPU has wasted cycles. Can you benefit from these cycles, and so on? So that's what we will be studying and trying to fill the gaps here. Now, as far as the going back to the Logi Sim simulator, this is a simulator that simulates our design. For example, if I design my computer with one CPU or with 2 processors, with one memory, main memory RAM, with some cache memory, with hard drive, and then I execute a program on it with a Logi Sim, I can simulate that process before actually I build the computer. We'll try to do that. Maybe we try something simpler. How does a CPU adds numbers in binary? How does it multiply with certain algorithms? So we'll look at these specifics, but mainly we are interested in the architecture of things, architecture of memory, architecture of peripheral devices, interaction between all of them, making sure how do they work all together as one coherent system, like a maestro who plays the music, and then every one of these pieces is going to play its own rhythm or tune, and then eventually it comes up as a musical piece. That's the whole idea of the architecture. In my career as a computer engineer, I find the most fascinating is really how to architect computing systems in order to achieve a required goal for your computation. Today with AI, artificial intelligence, we have different goals than we had before. With machine learning, anybody has a question to me? Jonathan, I think your mic is open and we are. Can you mute your mic? Costello, Jonathan, Lopez, can you mute? Okay, I muted you. All right. So this is what we will be doing throughout this semester. I will post I have not posted yet all my material. I was waiting for something to be done on my side, but I will post the syllabus. I'll post this small introduction piece, and actually the syllabus will be like this, will be the study of the CPU architecture, the memory architecture, external peripherals, interactions, and of course, I will take the issues like performance and reliability of a computer, and also availability of a computer. Look, these issues sometimes many people skip them, but I'm not going to skip them in this class because yes, I worry about producing a computer that's absolutely fast and reasonable and can generate my results in the best manner I want. But how reliable it is? Is it going to do that completely? Is it going to complete without failure? And how available is this? Whenever I need my computer to run a certain application, is it readily available for me, or it will tell me wait for a second or a minute or an hour or something? So these issues are as important as the design itself. So we'll be talking about them, and in the meantime, we will have some assignments that show we understand what we are talking about. And then, of course, as you know, we'll have two exams, the midterm and the final. Usually, between the, let me just put this in new slide for me here. Grading policy. So the grading policy I have. So we have assignments / quizzes. They could come in a format of quiz. I have midterm, I have final. My final takes the 50% that's already gone here. I have no choice for that. The other 50% will be divided between these guys So that's how we do. Now for late assignments, my policy is that you need to do the assignments no matter how late. Even if you are late for the date, I will still request you to get the assignment, and then there will be penalty for late assignments. You will get some penalty unless there is a reason. Of course, you can tell me there was some reason for this late assignment. I will always consider that. But usually, even if you miss an assignment 1, 2, 3, 4, 5 days a week, I would say you need to provide that assignment. If you don't provide the assignments, it will detect from your other grades, other your points. So you need to make sure you give the assignments no matter how late. Okay, any questions for me?
I do have one question, just to make sure that I'm understanding the definition of architecture. It's specifically intended to the relation of how that physical hardware reacts to execute a program, like specifically in relation to executing that program or the output of the process?
Absolutely, because
Okay.
that's the whole thing. We need the processors and the chips and the silicons to make sure that somebody understands what I mean, what I need from this program, and someone can give me the results. So all I need, the architecture, is how to make these CPU, memory, peripherals interact between each others and eventually produce the result I want, which is to process
Okay,
my
so it's the interaction that takes it from just separate hardware and makes it into architecture?
exactly.
Okay, thank you.
Yeah, that's actually, if you think about it, it's like an architecture of a building. When you assign the job to an architect, you tell him, look, I need a house. Probably the first thing he would ask, oh, who's going to live in the house? Oh, myself, my wife, 3 kids. Oh, so I know there are 3 people here, 3 kids and husband and wife. Do you have any other needs? So you will describe, maybe we have a pet. We need some garden outside. So the architect now will take all the uh, building blocks that he has, the glasses, windows, doors, bricks, ceilings, aluminum, etc. He put them all together. Each one will produce a function that complements the other one. So at the end of the day, you will have, let's say, a 3-bedroom house with a kitchen, with a living room, etc. And every one of them provides a comfort level or uh, achieves an objective which was initially needed by the client. That's a real architecture in the real world. In the computer system, it's the same. I need all the possible components, the building blocks, make them work together in a coherent manner so that you can give me what I need. So that's the correct understanding of architecture. Thanks. Any other?
I have a question.
Yeah, go ahead.
I was wondering, would this PowerPoint be posted?
Of course, yeah. I'll
Maybe in
post this
Canvas?
PowerPoint. Each lecture will be posted, and the recordings will be available on Canvas. It's already built in, and
Okay.
sometimes I have an advanced lectures in advance, but architecture, this is the first time I teach it at Capital. Usually, I will make available other slides from other professors, but mine will be posted as soon as we finish the class.
Okay. And I was wondering, I was looking at the assignments when you were talking about it.
Yeah.
I did see that you have homework 1, but it says to download. It says download homework one from file folder. Did you already upload the file folder, or you haven't posted it yet?
Oh, that I put a link for it from the net. So if you click on the link, you will find it. This is actually which I was looking for at the beginning, the tutorial for the Logisim, tool simulator. Yeah, you can. I think you can already use that.
Cause I don't see it. I clicked on the, I don't see any link for
Oh,
homework one yet.
okay. No, I think I did not put the homework one. It was only for the link for the simulator, so you will get.
Oh, for the simulator. Okay, okay.
Yeah.
Thank you.
Yeah, it's a tutorial, so you could familiarize yourself with this tool. That's it. And next time, I will go through one example, thorough example, how we use the tool, and then later on you can continue on your own. Okay. Any other questions? Okay. This is what I wanted to do in this first lecture, introductory lecture, so we get to know each other. And what is it that we are going to do in this class? Hopefully, we will enjoy this class and try to make it as valuable as possible. We'll touch on the future architectures, the more advanced ones, what's happening. Like the other day, I think 2 months ago, there was an announcement that China had produced the most advanced supercomputer in the world, which runs trillions of operations per second. So, wow, what's going on there? What's the difference between such a huge, big computer and my small PC in terms of architecture? You will be surprised that they both are similar, except in scale. Except just like vehicles. Vehicle is a vehicle. Every vehicle has an engine, it has tires, it has energy converters. There are basic components that work together to make your vehicle move. And then what's the difference then? Oh, difference sometimes in qualities and size and different functionalities that you add on to the vehicle. So we need to be able to see when we listen and watch, there is a huge supercomputer that does blah, blah, blah. So we will not, as computer engineers, to be taken at a surprise by that. Okay. If you guys have no further questions, I will let you go for this afternoon, and then I will post the files and the detailed scope of this course on Canvas. Okay.
Sorry, I do have one final question. If I
Yeah.
wanted to contact you, is there a preferred method, email, or is it just ask the professor on campus?
No, I'm not on campus. I will give you my email, which you can, let me put it right here. Actually, there is my email on Captech, M-I Malkawi at captechu.edu. That's the email. Now this one is forwarded to me to my personal email, just in case sometimes I have access to my Google Mail more. You can use it directly if you want, but at any rate, I will get it from here. So these are my, yeah, you can email me at any time you want, and I should be able to respond in few hours, no more than few hours. Now, of course, you can use the mailbox on Canvas, the one that we have. Where is that now? Here, this is the one. I think there is the inbox. That you can, oh, I think Jibril has already sent me an on the inbox here, but this one does not translate into my regular emails. But I do see that whenever I log into my Canvas, I can see it. You can do it here, your note, or you can just send me the email. Okay.
Hey, Professor, I have a quick question. I'm pretty sure you already answered this, but I just wanted to ask if the slides were going to be posted on Canvas. It's just my connection's been acting up sometimes throughout the lecture.
You mean this one that I have just did?
Yeah.
Oh, definitely. It will be within less than 24 hours. It will be on campus.
Okay. Okay.
So
Thank you.
that you could see my emails here. Yes. Sure. Any more questions?
Yeah, I have one. I'm sorry, I have this
No.
is just one question. It's just about the You said there is a tutorial where you link the way how to download the way how you
Yeah.
download Logisim. Do you think you
Yeah.
could show me that just where it is?
Oh,
so I
okay.
could find it.
Okay, let me
Mhm.
see. Just 1 second.
I just want to make sure I do have it. I don't want to get the wrong thing.
I had it in this file, Logisim tutorial, but looks like it did not save things, but I will get it right now. From where I got it from. And then Logisim itself here. Let me make sure that this is the one I used. The Logisim itself is a free download. Yeah. Oops. Here it is. So this is the link, and I will add it to the PowerPoint. To the last slide. Logisim tutorial. Although it says it's a beginner tutorial, but there is two parts of it for just the beginner, the one who doesn't know anything about Logisim. And then after that, you'll start watching the more advanced tutorial that shows you how to even build a whole architecture from scratch. So this is the Logisim tutorial, and the download, where I did download my so if I go out from here, yeah, right here. There is a download for the Logisim, and I will also add it to the PowerPoint slide.
Okay. Thank you. Thank you.
You got it? Good.
Yeah, I see it. I'm about to well, when you post the slide, I'm gonna get it from the slide.
Yeah, we'll get into the slide. Okay. So I put it in the slide. Okay. That will help a lot. Any other questions for me? Okay. Let me ask you a question myself. Where is my now? No, not this one. Okay. What's your expectation from this course? Let's start with first Alexander. What have you anticipated from this course, Alexander? Or what are you looking up to learn? Alexander is muted and probably not hearing me. How about Devon Wang?
Hello? Yes.
Yeah. What are you expecting from this course? What's your expectation? What would you like to achieve in this course?
I would like to learn how just I just want to have more knowledge on Logism and how the components work.
Okay.
Because I did take this course last year, but I did drop it because I wasn't like understanding it fully. But I do enjoy the way you're teaching because I feel like the way you're teaching is just you're teaching me like I don't know anything, and I kind of like that because I'm learning more. If that makes sense.
Okay.
It's kind of hard to explain, but I feel like the slow paced teaching I enjoy because I feel like I'm learning a lot about it, and I am about to take advantage of like the tutorial and like just learning more about how everything works.
Okay. Okay, great. I hope we can achieve your objective. How about Jonathan Castillo? What do you think? If I ask you the same question, what are your expectations? What are you looking up to in this course? Do you think you are?
I would say I'm looking forward to kind of understanding more about how like the electronics aspect of computers work. This is only like the second electronics course I've taken, and I kind of want to like, get like a more knowledge on how the hardware side and kind of like the electronic side works, because I do kind of understand how like the software works and stuff like that.
Okay. I need to make special efforts for your expectations, Jonathan, because there are three major issues in the computer system. One is how the basic units and arithmetics work, which we took in digital logic. How the electronics function, like in electronic engineering 1 or electronic engineering 2 course, where the transistors, capacitors, IC chips come into play. And then the architecture is neither. It's neither the software part, the programming, the software. It's not even the operating system. It's not even the electronics. It's how to make all of these things work in order to produce your results. So sometimes the architect for a building is the most highly paid in this whole project, but he's not the one who deals with the bricks and the units of the buildings. But without that architect, you will never have a building. So this is something to watch for, but I will try to cover at least one lecture on the electronic side of it. How does this, from the perspective of architecture? For example, I'll give you an example, so you will be looking forward for something. Usually, when you use electronic components consumes electricity, correct? So you have to have a current running into them. If you want to provide very high speed computer, these currents have to run at much higher speed, and more current, more power is consumed, which goes through the wires. What does this produce? Produce heat. What does this heat produces? Errors in the logic of the systems. So here is an interesting part which architecture has to deal with when knowing some of the characteristics of the electronics, the capacitors, the transistors, the wires, the nano wires at the very small scale, and then at some point you will see what if these wires running bits, zeros and ones. You know, the zeros and ones are, these are the basic numbers which we use in our computer system. And the 0 and the 1, they are very similar, close to each other in terms of the electricity that produces them. How do you distinguish between a 0 when its voltage level goes up by, let's say, 1%? It could become a 1, and if it becomes a 1, then that's an error. So you come from this perspective, the electronics become vital, and knowing them to the architecture. So we'll cover it from this perspective, rather than what is a transistor, how does a transistor function. Those things are, we take them in electronic course, but we will take this part of electronics, how does it impact the architecture, how the architecture demands certain level of optimization and design of the electronics. Okay. Okay, going to next, Jibril. What's your expectations? What do you think we are doing in this course? What are the yeah, go ahead.
My overall expectation for this class is just to understand more about how computer, like you were saying, how the architecture component is, how the overall structure of a computer works, and everything, and how each, I guess, each components of, if I'm getting it correct, each component communicates with each other, and how this can relate to the just like real world examples as well. Because I know technology is like changing every few years, so it's just gonna be interesting to learn more about that.
Good, okay, well said. Miranda, what's your own take on this question?
Really just to get a better understanding, like an in-depth understanding about the design of a computer and its inner workings, really.
Okay, that's fine. We will definitely cover that. And we are left with how do you spell your name? Samadarshi or Nagaraj?
Yeah, that's correct. Samadarshi. That's my
Samadarshi.
first name. That
Okay.
Nagaraj is the last name.
Okay, good. Here, let me hear your side of the picture.
Yeah, I guess I just want a better understanding of the hardware side, so I have a bigger picture of how all of it fits together. Regards to the digital and hardware, I just feel like I have a better time understanding and grasping concepts when I can visualize a bigger picture of it and how it all fits together.
Okay, good. I hope also, I want to add something more, is that no matter how much you hear about the advancement in AI and taking over the role of the engineers and people and maybe data scientists, because they can do lots of analysis. When it comes to architecture, the architecture is about, it's an algorithmic type of thinking that's way above and beyond what is called machine learning and AI. So the role of architect will never diminish in this field of computing. So that's something good about this type of courses and knowledge that we are gaining here. And I will touch on this throughout the course. All right. Well, thanks all, and we'll finish this class at this moment. Next Tuesday, we'll have a more elaborate class, and I will start with the first actually unit, which will talk about the CPU part of architecture in depth. Okay. If there are no more questions, then you can be you can leave this class, and we will meet next week, hopefully.
All right, thank you.
Sure. Thanks, guys.
Have a good night.
And you too. Okay.